This is our project in MATH156, differential equations. We will be solving for the solution of a differential equation and find the answer to the problem. The problem is a mixing problem. It is: a tank contains 1000 liters of brine with 15 kilograms of dissolved salt. Pure water enters the tank at a rate of 10 liters per minute. The solution is kept thoroughly mixed and drains from the tank at the same rate. How much salt is in the tank after 60 minutes? We will be using three manual ways, which are linear equations and integrating factors, separable equations, and methods of undetermined coefficients. Also, we will be using MATLAB to demonstrate the Euler's method. We need to find how much salt is in the tank after 60 minutes. The first method will be using linear equations and integrating factors to determine the general solution and find C. So, let's get right into it. First, we need to put it in a form where dq over dt is equal to the initial concentration multiplied to the initial flow rate. The initial concentration will be 0 since it is pure water, and the initial flow rate will be 10 liters per minute. Then, minus Q over 1000, which is the final concentration of salt after water is poured, multiplied to the final flow rate, which is the rate of how much water is drained, which is 10 liters per minute also. Then, we will manipulate the equation to put it in this form: dq over dt plus Q over 100, since Q over 1000 multiplied to 10 liters per minute will be Q over 100 equals to 0. This is a form where dq over dt plus p of t and the variable is equal to the g of t. To find the integrating factor, we need to do this. U of t is equal to the integral of p of t, and the p of t is 1 over 100. So, e raised to the integral of p of t dt is equal to the e raised to the integral of 1 over 100 dt. Therefore, the answer is e raised to t over 100. Then, mu of t will be used to determine the general solution. Q of t is equal to the integral of e raised to t over 100, which is the integrating factor, multiplied to 0, which is g of t dt plus c over e raised to t over 100, which is also the integrating factor. Simplifying, the answer will be c e raised to negative t over 100. Then, the initial condition says that there is 15 kilograms of salt at first. Therefore, at Q of 0 equal to 15. Then, we will equate it to the general solution, and then we will get C is equal to 15. Since the general equation is C e raised to t over 100, then we will input 0 onto t. Therefore, it will be C e raised to 0, and e raised to 0 is equal to 1, and C is equal to 15. Therefore, Q of t will be 15 e raised to negative t over 100, since C is 15. Then, the initial condition says that we need to find how much salt is in the tank after 60 minutes. We will then substitute 60 into the general solution. Q of 60 is equal to 15 e raised to negative 60 over 100, and you will get your answer, which is equal to 8.23 kilograms. Voila! That's how much salt is in the tank after 60 minutes. That's how we solve it using the linear method.
Hello, good morning. My name is Rovic R. Macabalo, here to present the separable method that we will use to solve the problem for our differential equation, which was a mixing problem. Here we start with the dq over dt equal to negative q over 100 which we got from the linear equation which we used earlier. We separate q to the 100 and the dt to the from the dq, and integrate it, and we'll get the integration of dq over q equal to negative integration 100 of 1 over 100 gt. Then integrating it, we get ln of q equal to negative t over 100 plus c. Next, we will apply the exponential, so we will get q equal to c e negative c over 100. And given the initial value that were given by the problem was at t is equals to 0, q is equal to 15 kilograms. Here we can see that at 0, e will be raised to 0, so will be equal to 1, q will be 15, and c will be equal to 15. So our final equation will be 15e raised to negative c over 100. Next, we will solve the problem, which was at t is equals to 60 minutes. What would be the value or the mass remaining? So at t is equal to 60 minutes, we will have q of 60, which will be equal to 15e negative 60 over 100. Using our calculator, we will get 8.23 kilograms. And that's the separable method used.
Good day, I'm Sham Peristan. Today I'm going to use another method, which is method of undetermined coefficients. There. Then we're going to use the equation earlier, which is q prime plus q over 100 equals to 0. Then we're going to make it a character equation, which is r plus 1 over 100 right there. Then we can determine the r, which is r is equals to negative 1 over 100. Then we're going to input it on our particular solution, which is qt is equals to c1 e raised to rt, and rr is equals to negative 100, so it is negative t over 100. And when when rt is equals to 0, q0 is equals to 15. So rc is equals to 15, because anything raised to 0 is equals to 1, and c times 1 is equals to c, so c is equals to 15. So qt is equals to 15 e raised to negative t over 100. That is our particular solution. Then in the problem, at t is equals to 60 minutes, q60 is equals to 15 e raised to negative 60 over 100, and we'll get 8.23 kilograms. And that is our final answer.
Hello, my name is John Stefan Hernandez, and I will show you how to use MATLAB in order to solve the mixing problem. We will use the Euler's method to approach the problem. The first 5 lines of the code enable the user to input values that are necessary to solve the equation. These are consists of the function, the initial time, the final time, the number of steps, and the initial value. The next line of the code is for the computations that are also needed in order to solve the equation. We use the for loop method because of the iterations. It is because of the nature of the Euler's method of continuous calculations until you arrive at a certain solution for the equation. When we execute the code, it will ask us the function, which is equal to negative y over 100, then the initial time, which is 0. Next is the final time, which is 60. Then the number of steps, which is equals to 50. And the initial value, which is 15. We will get the answer of 8.2024, which is close to 8.23 of the previous manual solutions, meaning that the program we made is correct for this equation.